Welcome back to our course, Algorithms and Data Structure. We're continuing in our process of working through various data structures, and the things that we're focusing on at the moment are on sorting algorithms. And we've talked about, in growing complexity, various algorithms that are there. And so the thing that we will be talking about now is this another Java interlude, and then we'll get into some more stuff in terms of sorted lists. So with that, we'll just move on to this one and have this short little interlude. So this is the textbook chapter contents that we'll be getting a chance to be talking about, mutable, immutable objects. So when a class is a public mutator or set methods, a client can use these methods to alter objects of that class. Although this ability seems reasonable, it is unreasonable if another class organizes those objects in a particular way. For example, the next chapter describes the ADT sorted list, which maintains the entries in sorted order according to any criteria you want, alphabetical order, for instance. The client can alter a name in the sorted list. It can destroy the order of the list. So let's talk about mutable objects. Many of the classes you have studied so far have private data fields and public methods that either look at or change these fields. As you know, such methods are called accessor methods and mutator methods, or alternatively get and set methods. An object that belongs to a class that has a public mutator method is said to be mutable, as we mentioned in chapter 7, because the client can use the set of methods to change the values of the object's data fields. For example, you saw the class name of two parts names in segment B16 of Appendix B. It has the following two data fields, private string first and private string last. To ensure the client, to enable the client to change the values of these fields, we give the class the mutator methods set first and set last. To look at the fields, it has the accessor method get first and get last. So let's use this class to create an object for Chris Coffee by writing the following Java statement. Name Chris equals new name Chris Coffee. Figure J61 illustrates the object and the reference variable Chris, as we're seeing right now. How can it be that the list, which we created before changing the name, contains the changed name? Remember that in Java, the list contains references to the actual objects, that is, the client places in it. So the list has a reference to its first item, but so does the client, which it has the variable Chris, as in figure 6J6, figure J62A shows. What about comparison classes? Although immutable objects are desirable for certain applications, mutable objects have their place. Sometimes we will want to represent an object in both immutable and mutable forms. In such cases, a pair of comparison classes can be convenient. The classes immutable name and name are examples of two such companion names. The object in both classes represent names, but one type of object cannot be altered while the other can. To make the classes even more convenient, you could include constructors and or methods that convert an object from one type to another. For example, we might add the following constructor and method to the class immutable name. And we'll try and read those to you, but similarly, we could add the following constructor and methods to the class name. So figure 6.3 illustrates these two class names in immutable name. And so instead of just talking about the actual Java code, you can see how this looks here in this table. Well, that's a short little synopsis, but we'll end it there and say thank you very much.